Okay, welcome to our lesson on correlation type. And so this quote actually is great. So it's just saying, I've never been in a bad mood near a beach ball at the same time. Is that causation or correlation? So there's actually, so we do want to say that there is some things that are cause and effect. But correlation always comes with the caution. Correlation does not imply causation. There's a lot of work to be done to prove that something's causation. Um, you can watch this video here. It's something, and so you could just imagine like what happens if one of those variables did cause the other. What would be the significance of those findings? We're going to be looking at the four types of correlation. We're also going to be looking at misclassifying correlation as cause and effect. So that's what we just kind of talked about there with the warm up, and then identify if the correlation was weak. The problem with using it. A cause and effect. Kind of racing against the battery here. A cause and effect, one of the cause and effect things is lung cancer and smoking. Canadian Cancer Society, you can go on their website and talks about what a carcinogen is. It's something that actually causes cancer when they have enough scientific evidence to prove that something causes cancer. There are different levels of causing cancer, and so they say that probable or possible carcinogens. They can also say that there's just not enough evidence yet. Fascinating link to go to if you want to take a look is just this list of agents that are carcinogenic to humans. So things that do cause cancer. A much simpler relationship of cause and effect would be something like the height of a ball bounce from where you drop it from. It's a very simple, take a bouncy ball and drop it from different heights. You're going to get different heights. A common cause, you can watch this video here from Freakonomics. They're talking about ice cream and polio, again, picking on ice cream. A common cause is there are two variables that are caused by a third outside factor. So our weekly Aboriginal income versus non-weekly, there were a strong positive correlation, but there's a common cause there. And so you really need to figure out more evidence to link that third factor to the two, but you can brainstorm ideas. So what might be some common cause factors that link Aboriginal income to non-Aboriginal income? A reverse cause and effect is a great video talking about, again, ice cream and drownings, but also talking about some more serious implications of cause and effect. So the question is it X causing Y or Y causing X? In the video, they talk about nearsightedness. Using a nightlight causing nearsightedness, and so how they had to actually see that to reproduce that and say, well, you know what, nearsightedness is genetic, and it's nearsighted parents that want the light on. So it's nearsightedness that's causing the nightlight to go on, not the nightlight causing nearsightedness. Another example is law enforcement. So if you increase your police force, you would think that there's more charges laid. So if the number of charges laid was measured as to say, oh, there's more crime, then you could say if you raise the police force, you're going to raise crime. But in fact, the number of crimes, when they go up, that's why we're getting more police officers. Accidental correlation. This is a lot of fun website to go to, spurious correlations, and there's a book on it too. And so this one's talking about divorce rate in Maine versus the per capita consumption of margarine. At a 99, an R value 99, which is really high. Question with accidental is you got to ask if it's common cause. So they might not seem like they have anything to do with each other, but there might be a third variable that's affecting it. So population, for example, anything that has a steady increase in time, population being one of those, they're going to be correlated with anything else that's steadily increasing in time. Weak correlation, so say you fit a model and you get a line of best fit, you're always going to get a line of best fit. So say, for example, we said if you brush your teeth 5 minutes a day, then you're going to get a 90 in school. For every increase in minute, you're going to increase your percentage in school by 10%. That's kind of interesting, but like, what if we found out that the R value is 0.23? That's a weak correlation. The scatter plot would be all over the place. Really, there would be no relationship between the variables, and any relationship that came up could just totally be random. And those are the four.